Okay, so we've been doing a lot of programs with factoring and prime numbers and stuff, and there's a couple more Project Euler problems I want to tackle using these skills that we're building, just kind of getting ourselves familiar with the way that the math implementation in Java is a little bit different than Python, which is the language that most of us know already. And a lot of them involve finding factors and primeness of kind of big numbers, and we in an earlier program we learned how to use long integers, which hold bigger numbers than regular integers, to get around part of that problem. But the other problem is if you use this kind of brute force method of finding primes, just dividing by all of the possible factors, the bigger the number gets, the slower and slower and slower that process gets. We'll talk about the big N notation for how the length that the amount of individual steps that need to be executed in a program increases with the number. And whether that increases linearly or quadratically or exponentially depends on your algorithm. And the algorithm we have for finding prime numbers is not very efficient. I tried to do Project Euler, I think number 3, I can't remember which one it was, but ones where you have to find the primes up to 2 million. And I only got up to like 180,000, or maybe it was 1.8 million. The program got slower and slower and slower and slower and slower, and finally CodeHS just kicked me off. So what we want to do is see if we can come up with a more efficient way to find prime numbers. So yeah, let's go. We're going to use a method called a prime sieve, and the mathematician who's usually credited with figuring out this method is Eratosthenes. Eratosthenes is the same guy who measured the circumference of the Earth by measuring the lengths of shadows in 2 different cities. Smart guy, up to all sorts of stuff. And the way the sieve of Eratosthenes works is this. Imagine we want all the primes up to some number, say 1 million. We just make a list of all the numbers up to 1 million. And then we cross out all the multiples of 2, and we cross out all the multiples of 3, and we cross out all the multiples of 4, and we cross out all the multiples of 5. And once we've crossed out all the multiples of something, the numbers we're left with, when we're done, are the primes. That's going to be a faster way to generate primes because we only have to compute multiplications n times, where n is the number that we're going up to. We don't have to divide every number less than n by every factor less than that number. So the speed of this algorithm should be faster. And we'll test it just by seeing if we can get the primes up to 2 million without bogging down CodeHS, which is what happened to me when I tried to use our brute force method. If you want to learn more about the sieve of Eratosthenes, I've given you the link to the Wikipedia article. So I've got my scanner, because I'm going to ask the user for a number. How far do we want to look for primes? And then we need to import our ArrayList utilities in order to use those. So the first thing I'm going to do is just the standard prompting a user for input. So I'm going to paste a big block of code here so you don't have to watch me type. I'm going to say to the user, hey user, give me an integer, and I will find you all the primes up to that integer. Okay, so this is the usual business. We create a scanner object. We call it scanner. This is the syntax for creating a new scanner to read an input. And then I'm going to read in a number from the user. I'm going to call it maximum. Maximum is the highest number we're going to look at. So I'm going to find the primes up to the integer maximum. I'm currently just making maximum an int. If I wanted to go up to 2.2 billion, I could make it a long instead, but I think an int is going to do it for us for now. I don't think we need to worry about numbers quite that big. So the way I'm going to do this is not the most efficient way, but I think it's the clearest way. I'm going to first create a list of all of the integers up to some maximum. So I'm going to need an array list, and I'm going to call it number list. And I'm going to need another list that's just the prime numbers. In other words, that's what I'm finding. I apologize for that. I'm trying to talk and type at the same time, and my indentation is suffering. Okay, so there's two lists. The first is going to be just a list of all the numbers up to maximum. I'm going to call that number list. And the second is going to be a list of which ones of those are primes. I'm going to call that prime list. Okay, so I asked the user for a maximum. I create an array list called number list, and I'm going to fill that with just all the numbers. And then I'm going to check to see if they're prime. I'm going to create a new list of just those numbers. Before I do that, I need to know which ones in my first list are the primes. And I'm going to create a list called primeness list, which is a big kind of awkward name. But that's going to be a list of booleans, just true, false, false, true, false, false. For every number in the list, it'll be true if it's prime, false if it's not prime. Okay? So as I find numbers that are prime, I'll mark them true or false, depending if they're prime or not. So I have three array lists, one for all the numbers, one for whether or not that number is prime, and then at the end I'm going to pull all the prime ones out and put them into a list called prime list. So I've got three array lists in my program. The first thing I'm going to do is I'm going to initialize the number list just by filling it with all the numbers up to my maximum. Okay? So I got a for list. For integer I equals 0, less than or equal to my maximum, make I one bigger every time. Add I, the number I'm counting up, to the number list. So this is the syntax to add the counter I to my array list. I've done something here I just realized that I don't think we've done before, which is we are declaring and initializing this counter I inside the for loop. I'm not sure we've done that before. I'm not sure we've initialized the variable inside, or sorry, declared the variable for the first time inside of a for loop, but you're allowed to do that in Java, and the syntax is this. So this initializes the counter I in the loop. Initializes counter I. Okay, let us just test this before we go any further. I'm going to need an end bracket here. Ends the for loop. And I'm going to just make myself a print statement. Let's see. Here are all the numbers up to your maximum. The program doesn't need to do this. I'm just doing it to make sure to troubleshoot the loop and make sure it works. So I'm going to then print. Actually, I should make this system out print, not print line, and then have a colon and then a space, and then just a system out print line number list. I'm not sure. I copied and pasted and wound up with a stray curly brace in there. I'm not sure where that was from, so we'll go ahead and run it and find out where that stray curly brace was from. Let's go ahead and run it. Make sure there are no errors. Yeah, probably a semicolon somewhere. Oh, that extra bracket was just supposed to be parentheses. Oh, it's here. I forgot to close that parentheses. And semicolon. Semicolons all good up here. Let's try that again. Another semicolon, maybe line 36. Oh, forgot my parentheses. Let's just do 20. Here are all the numbers up to your maximum. Notice it starts at 0, which we want that because Java starts numbering arrays, just like all programming languages, I think, start numbering their arrays at 0. And we want the index of the array to correspond to number. So 0 is at index 1. Index 0, 1 is at index 1, 2 is at index 2. And it prints all the way up to 20, which is the number I gave it. That's because this says less than or equal to maximum. So this works. It just takes a number and puts all the numbers up to that number in a list. Great. I'm just going to go ahead and comment these out for now. We don't really want that. What do we want to do? We want to initialize the primeness list I talked about. In other words, for every number in the list, we're going to say if it's prime or not prime. So true if it's prime, false if it's not prime. And the way this is going to work is, let's make them all true, and then as we multiply and find factors, we'll mark them false. So we're going to initialize the primeness list just by making everything prime, by making them all true. So I'm going to create, or I already created my list, primeness list. So for I equals 0 up to maximum, make I 1 bigger every time. I'm going to just add the word true to my primeness list. So my primeness list is just a list of all the numbers, and it's just true, 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 true. Okay, we're going to assume they're all prime until we find otherwise. Okay, and this ends my for loop. So now we've got two lists. All the numbers, and then just true, 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 that many times. Now, we're going to go through all the numbers from 2 up to how far? We don't have to go up to the maximum. We don't have to go up to half the maximum, right? Because you can't have any factors that are greater than yourself. Well, let's think about that. We'll just make it go up to the maximum for now. And we're going to mark the non-prime numbers. So again, apologies for my indentation as I copy and paste. The indentation in the place I'm copying from is not the same as the indentation of this program. So here's my loop. I'm going to start at 2. Don't need to start at 1 because everything's divisible by 1, right? So I'm going to start at 2. I'm going to go up to maximum. We might change that to half maximum later. And then every time my number gets 1 bigger. And I'm going to multiply that number by all the other integers. And I'll make this one only go up to half. Okay? So I'm going to start with 2. I'm going to multiply it by 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way up to my maximum. And then I'm going to take that result that number times n. Oops, times n. Goodness. Number times n. And what am I going to do with it? Say I do number equals 2 and n equals 3. Maybe we should call these first number and second number, or number and factor. Whatever. I've already chosen my variable, so I'm stuck with them. So I have 2 and 3. 2 times 3 is 6. Since it's a product, it's not prime. Then I'm going to do 2 times 4. 2 times 4 is 8. So 8 is not prime. Then I'm going to do 5. 2 times 5 is 10. So 10 is not prime. So I'm going to set that element of the primeness list. And the way I do that is with a method called set to false. And this is what that syntax looks like. False. So multiply the numbers, then set that element of the primeness list to false. So I multiply 2 times 3. I set the 6th element of my primeness list equal to false, because I know that 6 isn't prime. I do 2 times 4, then I set the 8th element of the primeness list to false, because I know that 8 is not prime, because it's 2 times 4. So as I go through the numbers in this double loop, I'm multiplying every number by every other number and sort of crossing off all the ones that I get. Does it make sense? It's a little complicated, maybe. So then I need to end my inner for loop and my outer for loop with a curly bracket. Okay. And then I need to end my for number loop. Okay. So what I should have now is a list of trues and falses where the primes are true and everything else is false. Let's test it and see if that much works. Here are all the primenesses. Is that even really a word? It's a word I just made up. Here are all the primenesses up to your maximum. Let's run it. Well, first of all, let's look for missing semicolons. There's one there. I think that's the only one. All right, so let's give it 10. Okay. So I give it 10. It puts the numbers 1 through 10 in a list. And then it goes 2 times 1 is 2. Well, it doesn't start at 1. Okay. It does 2 times 3 is 6. So 6 is false. 2 times 4 is 8. So 8 is false. 2 times 5 is 10. So 10 is false. Okay. Will I... And so what should my output look like? It should be true, true for 0 and 1, because we're ignoring 0 and 1. And then true for 2. And then true for 3. So it should be true, 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 true. Then false for 4, true for 5, false for 6, true for 7, false for 8, false for 9, false for 10 if it gets to 10. Oops. I just only hit run twice. Let's try it. Let's just give it 10. 10. Okay, so here they are. So it's 0, 1, 2, 3, and then 4 is false, 5 is true, 6 is false, 7 is true, 7 is prime, 8 and 9 and 10 are not prime. So it works. No, this is not what we want. We don't want just a big, long list of trues and falses. We want a list of the primes. So now what we do is we go through this list and say, if it's true, put it in a new list, which is our prime list. Okay, we created a list called prime list up here. So now we're going to go through all of the elements in that list and say, if they're true, add them to the prime list. Okay, so how do we do that? Do it like this. So we're going to start with 2. Forget 0 and 1. 0 and 1 can't be prime. Up to our maximum. So there's our for loop. If primeness list, and we use this method called get, so it reaches into primeness list at n, it says, is it true or false? If it's true, then add n to our prime list. Okay, so we're going through the primeness list, the list of trues and false. And if we get a true, when we look at index n, so we're going n equals 0, 1, 2, 3, 4, 5, 6. Or actually not. We're starting at 2 because 2 is the first prime. We don't consider 0 and 1 prime. So from 2 up to maximum, if the primeness list element is true at that index, then add the value stored there, or the index of that. It's not the value stored there. The value stored there is just true and false. It's add that index to my list of primes. Okay? Again, stop and think about it if it's a little bit unclear. I'll try to comment this code really, really aggressively. In fact, maybe this is a good example of a way to show you guys how to comment your code really, really, really aggressively. Okay? This should be a comment. I think we're probably good. So now we need some output. We'll take this debugging output out, and we'll put the real output. Paste. Here are all the prime numbers up to your maximum, and now we're going to put primes list. Did I call it prime list or primes list? I called it prime list. Okay, so print prime list. Okay, let's run. And we'll do a couple of different things. We'll give it a number that, oh, one error. Reached end of file while part of 60. Oh, this, I'm missing a curly bracket. This is the only thing we're doing in that for loop, so I'll go ahead and add the curly bracket there. Okay. Little tiny typing mistakes, that's fine. Let's do 10, because we know what the answer should be. 2, 3, 5, and 7 are all the primes up to 10. Okay. Let's do an interval that ends with a prime to make sure it gets the last one. I think when I was debugging, I used 31. All the prime numbers up to my maximum. 2, 3, 5, 7, 11, 13, 17, that's good. 19, 23, 24, 25, 26, 27 are not prime. 29 and 31. So there we go. Yeah. We could add a feature of this to have it count them. And we can gradually work our way through the documentation of the ArrayList class in Java and learn how to do all of these things, how to get things, how to set things, how to add things, how to remove things, and so on. Another way we could have gotten our list is to, when going through our numbers, every time we find one that's not prime, we just remove it from the list entirely. And we'll look in a later version of this how to make it more, how to make it faster. Because this isn't the fastest this could work. Why? Because let's go back and look at here where we start crossing things out on our Sieve. What are we doing? We're going 2 times 3, 2 times 4, 2 times 5, 2 times 6. Cross them out. And then we go back and do 3 times 4, 3 times 5, 3 times 6. Cross them all out. And then we do 4 times 4, 4 times 5, 4 well, wait a minute. We don't have to check the multiples of 4 because multiples of 4 are all already crossed out because we did 2. And we don't have to check 6 because we already did 3. And we don't have to check 9 because we already did 3. And we don't have to do 10 because we already did 2. So we shouldn't have to check all the numbers. We should only have to check the ones that haven't been crossed off. So we could put a little if statement in here that says, if primeness is still true, then do this step. If it's not, skip it. In other words, when we're looking for factors, we really only need to check the primes. So as we find them and mark them prime, those are the only ones we have to check. The other thing we could do is just take them out of the list entirely and have a list that's only the primes and pluck the non-primes out as we go. There are a couple different ways to go about this. What I want to do right now is to just test this with the number 2 million, because the Project Euler problem I was trying to do asked for something about the prime. I think it asked to add up all the primes below 2 million. And I couldn't get there without timing out. So what if I run it and just give it 2 million? Now it might take a while to print those all out. 2, 1, 2, 3, 4, 5, 6 zeros. Boom. Done. Look at that. 1,999,993 is prime. Okay? So we have now a way to generate a list of primes quickly. Notice we have to know where to stop. The sieve fills up until it gets to a particular endpoint, and then it stops filling. We couldn't find the first 2 million primes this way because we wouldn't know when to tell our sieve to stop. But we can find the primes up to some number because we just keep multiplying until we get up to that number and cross out anything that has 2 factors. Pretty cool. So, can we do Project Euler number, which one was it? Go back to the archives. Largest prime factor, it wasn't that one. Summation of primes. Find the sum of all the primes below 2 million. So we should be able to just take that list that we just made. We just listed all the primes and add them all up. We might need a long for that. I don't know how big the sum is going to be, but it's going to be pretty big. If it gets bigger than 2 billion, we've got to use a long integer. That's okay. We know how to do that now. So let's, we're also going to need to do one more thing, I think, which is to find the length of an array list so we know when to stop pulling elements from it. And we might even, maybe, want to look at, I lost my train of thought there for a second. We need to know how many things are in our array list. And we also might want to look at if Java has a built-in method for just adding up everything in an array list. Maybe it does. Maybe that's something you guys can look up on your own between now and the next video. So in the next video, we will take what we just did and really, really quickly use it to solve Project Euler problem number 10.